So, okay, the slides are up. So, just random fact, in 1936, Russians actually made a computer that ran on water. Anybody heard about the fact? I also didn't know. That's what you do basically when you're jet lagged and wake up at 3 a.m. and wondering what you need to do. And what's...
Water or vodka?
Good question. I'll go and do a fact check. So, moving on. So, as the slide, the big font says, I am Atish, work for the Western Digital, and I'm here to talk about the Supervisor binary interface that's known as SBI in RISC-V and what the future looks like for it. Here's a brief agenda of today's talk. I'll briefly introduce to give you an overview of what's SBI, what's the current status of it, what are the limitations, and then how we are thinking to extend it so that it can be a clean, better interface. And then I'll talk about the OpenSBI project, which just we made it public like a couple of days ago, and we'll have a couple of cool demos for you to see. So to start with, what exactly is SBI? So just to give you an overview, how many guys have actually worked on RISC-V interface or known about SBI? 3, 4. Okay, it's good enough audience. So just to give you an overview, so SBI is a supervisor binary interface that gives a clean separation between your supervisor mode and machine mode. So anything that machine mode is not exposed to the S mode, that's basically implemented via an SBI, which is a similar interface you can see between ABI and SBI. And that interface, by that interface, supervisor mode talks to your supervisor execution environment, which is basically on bare metals, it's a M mode. So what's the, if you have any of you closely followed what's being discussed in the mailing list recently, a couple of months ago, there's a huge difference of opinion saying what exactly the SBI's future look like. Should it have all, or it should not be exist at all? This all kinds of spectrum. I'm pretty sure if I do a vote here, it's probably split by half and half. So to me, it's not surprising because it's kind of a double-edged sword where you start putting a lot of stuff in SBI, it becomes a mini OS, and then it becomes a big firmware, which becomes big and messy. But as of now, where it is, so if we can make it a clean interface, and if we can go forward and keep whatever necessary required in it, it can help RISC-V achieve what it needs. And something like any architecture limitation that's now present, but maybe in 2 years down the line, that architecture limitation will not be there. We can add it in the SBI, and then in future, we can adopt the operating supervisor OS to implement that instead of SBI. So that's where having a good specification and implementation makes sense for SBI. So currently, it's implemented by BBL, and this how it works is basically it's a supervisor trap and emulate. So you basically trap into M mode using an eCall instruction. You pass your SPI call number in A7 registers, pass your arguments in A0 to A2 registers, and then in case of you want to return something, you return using a clobber register A0. It's the existing implementation is documented in one of the GitHub repository that's mentioned here. Now, here is the current interface that exists. So we have a timer call and a Y timer, because currently RISC-V doesn't have a timer register that can be accessed through S mode, which can be used to program the timer. So when you get the next, when do I get the next periodic event? That's where it comes into picture. Then we have console and IPI. So whenever we send an interprocessor interrupts to other CPU, we need to go trap into the M mode and then send it, because the client access, everything is M mode only. Similarly, TLB flushing, we have like all the memory model interfaces. For TLB flushing, we need to call an SPI and a shutdown API. So what's the problem with it? Why it is limited, or why do we need to change it? First, it's fixed. So there are 8 APIs, those are fixed. There is no present way to extend it. And even if we add new functionality, we are probably going to break the backward compatibility. That's where we need to have a specification that allows modifying it, adding it, or removing functions from it without breaking backward compatibility. What kind of features we need to add? Something like power management, or let's say CPU hot or CPU hot plug, which is basically necessary and required for any kind of systems that you build today. So coming back to the specification that we talked about, now I think Alex is in the room, so there is a lot of discussion about how we define the scope, like where do we stop it, defining the SBI scope. So that is my view, saying it shouldn't be, as I said, it shouldn't be treated as a kitchen sink. You cannot dump any feature you want, or vendors should not dump any features they want. Whatever functionality they suggest, if it is absolutely necessary, then only it should be implemented SBI without breaking the backward compatibility. So backward compatibility is absolutely necessary. We do not want to go ahead and have something that's not going to, let's say, work in the previous version. And we all agree that we see that there is a future where RISC-V can be the ubiquitous ISA among all the devices. So no mandated usage should be there of, let's say, this is DT-specific implementation or ACPI-specific implementation. It's open to adopt anything, and we probably want to keep it in that way. And any functionality that currently SBI has, probably we should allow it to be replaced by your S-mode software and feature. So something like a timer. So there are discussions about having a S-mode timer registers that will allow to remove that M-mode SBI call. And these are the only some of the few points that defines the scope. There are a lot of other discussions happening. So anything else, as this is a evolving discussion, we can keep on adding as long as it makes sense. And we define the SBI within that scope. Now, how the specification working will progress. So as of now, it's been decided that the specification will be part of the RISC-V Unix class platform specification. It need to be approved by the working group, and it need to be you need to have an implementation before the freeze. Now, why the working group? Again, there is some discussion about why we are going to a closing discussion, why it's not happening in the mailing list. Actually, it is an open discussion. It's not forming a working group doesn't mean that it's a closed discussion. In fact, the proof that I'm talking about it without having the first meeting of the working group is a proof that it's being discussed in the public forum with everybody, and then we are taking inputs from everybody. But the objective of the working group to make progress on the specification continuously and finalize it within finite amount of time. We cannot have years and years just talking about it, but not actually finalizing spec and not implementing it. And also, working group makes sure that there is one reference implementation available for every SBI specification that we make, or every SBI modification that we make. So that's decided that to keep the discussion focused, we'll have a minimum base mandatory spec, which will define just the layout, saying how the versioning should be managed and how the functionality should be managed. That's it. That will be mandatory for every future SBI versions. Then there will be any other, something like power management, either CPU or system. All those will be an extension to it. So that will be that can be worked as by different people in the same working group, and then those can run in parallel while based on the layouts defined by the base specifications. So let's take a look what all is being proposed as a base specification. So calling convention, whatever the calling convention exists today, it also kind of works. The only thing I think that's suggested by Ron a couple of months ago, so we can have a return value with a structure, which gives you a flexibility to distinguish the difference between whatever the SBI function returns and what the SBI library wants to return. So those are two different things, and this is the way to distinguish it, and that's where RISC-V ISA came in as a help, because it defines that ABI defines that we can have 2 registers as a return value. Other than that, the existing calling convention, which is documented in the GitHub, stands correct for the even updated proposal. So the new thing that we are going to add is a versioning scheme, which is basically a major and minor, which is standard versioning scheme that everybody follows. 16 bits, minor 16, on the last 16 bits, upper 16 bits are basically defined the major version. The existing current legacy version will be 0.1. So that's called legacy. We hope that we'll get rid of it one day. The base version that we're talking about here, which will be mandatory, will start with the 0.2. And going forward, depending on what kind of feature we're adding, we'll keep on adding the version numbers. Now, there's a function ID that we need to define. So it's again an unsigned 32-bit integer. So the function ID is basically a combination of function set and a function type. Function set is similar kind of functionality that can be grouped, is a function set, and the function type is basically individual functions feature of a feature that's being added. So something like, let's say legacy. Legacy is a function set. All this base specification we are discussing, it's a function set, which is basically statically defined IDs that are assigned. Then we have, let's say, CPU power management or system power management. All those IDs are predefined assigned. And we also have something like reserved region, which allows anybody to, let's say, somebody is experimenting with a SBI call, and we are not sure whether that fits into any of the function ID or a function set, or you need to have your own function set. So that's where reserved comes into picture. You can pick any number from the reserved, and in future, if you want to keep it that way, you can keep, or you can move it to any of the function set. The last, which is, I guess, most controversial thing, is the vendor extension. So whether we need, I hope we don't have to, but since ISA allows you to have vendor-specific ISAs, there may be a future where, we don't know, there may be a future where vendor might absolutely need it. If we don't provide it now, and they need it in future, we might breaking the compatibility. So let's see if it makes sense to keep it. Again, it's just a proposal. It's still being discussed, so it's not like finalized and set in stone. So there's a scope for revision for everything. Now, this is the base version functions. These are the only functions that will be mandatory to implement and basically will be part of the SBI version. So something like, it's a no-brainer, we need to have a version. So SBI get version, which returns the specification version. Then there is SBI implementation version, which is basically provided by the software that's implementing the SBI. So something like, let's say, OpenSBI provides this one, and OpenSBI gets an ID, something like, let's say, 1.2. And then there is another software, let's say Core Boot implements SBI. So Core Boot gets 1.3. So that helps to identify the difference. So to know that supervisor mode, that which software actually implementing the SBI. Similarly, we have function set and function type. It's just a probing of whether a particular function set exists, and within that function set, whether a particular function type exists. Then we have get vendor ID and machine implementation ID, which basically returns you the value that's stored in mVendor ID register and MIMP CSR. And this vendor ID and MIMP helps you to identify which particular vendor specific functions, if they in the future, if they have, or if we have a vendor specific APIs SPI, that helps to identify which vendor belongs to which function belongs to which vendor and all. Lastly, we have an implementation ID, which basically, I switched the earlier one. So earlier I was talking about the implementation ID, which is basically a specific ID for SBI implementation. And the second one was SBI implementation version, which is, so something like OpenSBI or BBL or Core Boot, they get an implementation ID which is fixed, let's say 1.1, 1.2, and 1.3. And then there is open implementation version where OpenSBI will have 0.1, 0.2, or 0.3, 0.3. Similarly, Core Boot might have a different version. So that's where they communicate between what features, what specification they implement, what feature they support, and what software they are talking about. So this is all about the specification, how SBI specification will be, what will all be implemented in the specification. But what about the implementation? We need a solid standard implementation that provides the SBI, that not only provides the implementation after the spec is frozen, we should also provide it while the discussion is going on, so that we know whether whatever we are proposing or somebody else is proposing or what's being discussed makes sense. So currently we have two options. BBL and Core Boot provides the separate SBI implementation. In future, there may be more fragmentation. There will be more different SBI implementation because everybody goes and tries to implement their own, because everybody's code structure, everybody's open source model is different. And so that becomes a pain, difficult to track and maintain those SBI changes. Everybody now, we don't know which version, who implements which version, and then how they are backward compatible. Then with the BBL has been really useful and helpful until now in bringing up all the RISC-V systems. But this is a fundamental problem in BBL, is that it has a tightly coupled platform code and SBI code. So if you want to swap out or modify SBI code without changing in the platform code, that becomes messy. Or if you want to add new platform support, that becomes difficult. So keeping in all this mind, that's where the OpenSBI comes into picture. That's why OpenSBI is being developed. So let's take a look what exactly OpenSBI is. So it's an open source SBI implementation project. So all we need is a standard implementation that everybody can use, which adheres to all the specs that we propose. It's driven by a community, the open source community, and it has the most permissive license. So you are open to take it, implement it, modify it, whatever you want, and we would like to contribute back so that it grows and becomes the standard project. It's fine to have another SBI implementation as well. It's not mandated. It's not nobody's saying that this is the only SBI implementation that should exist in future. But this is a reference implementation. At least we'll make sure that every specification is implemented. If there are a couple of other, that's still good. But at least I hope that this will prevent 10 other to fork it. Couple of other is okay. So what does it actually do? So it builds a static library that that's just a SBI implementation, and any of the mode bootloader can link. It also provides you one reference implementation for your platform code and your firmware code. And it also uses PMP to protect your firmware. So it's well documented. Go and take a look at GitHub repository, and it's all standard GitHub process is followed. So if you have an issue, raise it. If you have a doubt, just ask the question in the GitHub. There are a couple of pull requests and issues already pending in the GitHub. So I said a lot of things about this is what OpenSBI does. So let's see how it does, what exactly it builds, and what I said is how the objective is achieved using OpenSBI. So first, it builds on libsbi.a, which is just an SBI implement. It's a static library, and it just implements the SBI. That's it. It doesn't have any other feature. So any mode bootloader basically can link this SBI implementation for their SBI feature, and they don't have. So this prevents forking of SBI implementation, varying degree of SBI, for using different SBI implementation, and everybody coming up with their own. So, and as I said, we'll make sure that every future proposed SBI specification or extension will be implemented in libsbi.a. And it also builds on libplat.sbi.a. So libplat.sbi.a is like a container that has the libsbi.a. It uses the libsbi.a to use the static get the SBI feature. So again, what the difference between libsbi.a, plat.sbi.a, as the name suggests, it also has the platform support. So all the platform drivers, whatever the minimal platform driver required, that's what the plat.sbi.a uses. So any of the vendors or a SOC platform support require, let's say they already have IP blocks that are already implemented in OpenSBI. They just take this one and build their own firmware. So what all platform we have supported? We already have support for QEMU Vert, QEMU Sci-Fi View, obviously Sci-Fi Unleashed. So we have complete support for Unleashed, and we also have CanWrite support, which is like $20 amazing disk sky board which can run FreeRTOS, do face recognition and whatnot. So almost I can say that any SoC that's available that's supported by OpenSPI currently. If not, if anybody has an SoC and that we are not aware of, please talk to us. We'll try to make sure that it's also supported using OpenSPI. So the last piece that OpenSPI builds is a firmware binary. So all this firmware binary, it's just a reference implementation to showcase how PlatSPI or libSPI is used. But it also complete platform-specific bootable binary. So you can just take it and use it for your own project. If it is a different platform, you just add your platform support, and then you get your platform firmware binary completely, and you just go ahead and use it. If you're trying to use the existing platform, that platform, let's say Unleashed platform you need, just build it, and then you will get the binary. We'll have obviously binary releases as well, which will directly work on the Unleashed platform or any other future platforms that come up and we have access to. So there's two ways of building the firmware. One is basically with a payload, which is a standard mechanism of giving you, you give the next, so next is bootloader or next is image as a payload to OpenSPI. OpenSPI combines it and boots it and make sure that from OpenSPI it boots the next image. There is a feature that we can add device tree as a separate file. So any of the device tree modification that you want, you can go ahead and do with it. So the next type of the firmware that uses is is using a jump address. So that's, let's say the previous stage to the OpenSPI knows how to load the next stage to the OpenSPI. So in that case, you don't care about the payload. The payload can come from anywhere. So you just provide the jump address, and then it makes sure that it will jump to the next address, which is being loaded by the previous stage. Now, as I said, vendors can choose either way to, depending on their flexibility, either way to build their firmware or just use as it is. So all this talk is required to standardize the boot flow. So that's the big mess. I think Carsten also mentioned, saying we need to standardize the boot flow. We need to follow what every other, let's say ARC64 or x86 or every other standard boot flow that's being used. We need to follow that model, and that's where all the CI, everything comes into picture, because nobody wants to change only for RISC-V. So we need to support whatever the upstream, all the bootloader support. So this is the current boot flow. So we have ZSPL, then FSPL, which is like M mode, ROM-based binaries, and then it loads BBL. BBL basically combines the Linux image into it, embeds into it, and then DTs. There is no way to separate the DT from the kernel image. There is no way to do the network booting. That's where OpenSPI has been implemented to address all these issues. So how does the OpenSPI feature as the standard boot flow? It's the same model, just the OpenSPI replaces the BBL, but here you have the ability to create separate DT files, and you can boot complete Linux. Full SMP support is there, and you can boot. Basically, you give a Linux payload to a OpenSPI, and then it just boots Linux. But the upstream model that I was talking about is this one, which I'm really excited about, saying it's the same thing, ZSPL and FSPL. Then we have OpenSPI, which is M mode, which boots into your U-boot S mode, and then you just provide the Linux image into the U-boot as every other implementation or every other architecture does it. So you have a kernel image, you just load it via network. That's where it's also supported. So this is the standard flow. So U-boot becomes the last stage bootloader, not a BBL or not OpenSPI, and you load the image via TFTP boot. And as of now, it can only boot one core out of the. It builds SMP and boot SMP, but we can bring up only one core in Unleashed because there is no support in U-boot SMP support. So as soon as we have a hard power management, we can bring up all the CPUs. It's just put in the WFI loop in OpenSPI. So this is just a quick instruction overview. The detailed instructions, everything is available in docs and for each platform. So this is just a quick way to show you that how do you build and generate the binaries. So this basically two arguments. One is platform. So you say whether it's a QEMU or Sci-Fi platform, and the next one whether you want to give a payload path or you want to give a jump address. So this is how you provide the Linux image as a direct payload. So you just assign saying make platform QEMU vert, and then this is my Linux image path, and then this is a standard way to run QEMU RISC-V, and you give the rootfs file as the QEMU drive file. If you are using U-boot to load it, just say same thing, make platform QEMU vert, then you give a payload path as a uboot.bin, your uboot binary, and then for running it, you just run QEMU with here. Notice that there is no rootfs required because we are using U-boot. So it will boot into U-boot, and then you follow standard U-boot model to load your kernel image. Similar process in the Hi5 Unleashed as well, where you just give your platform as the Sci-Fi FU540 and your payload path as the kernel image, and for U-boot, same thing. And this is a screenshot of OpenSPI booting Linux directly. I don't think it's visible, but anyways, I have a demo, so don't worry. This is another screenshot which was basically OpenSPI booting Linux using U-boot. So I have a couple of demos that I wanted to show. Let me see if demo gods are happy with me and if it works. Otherwise, just a backup video I'll show you. You already know how do I slide the windows? Yeah. Oh, it came. Come on. Okay, I have it. Okay. So here is my TFTP boot server, and then here is the other window, and okay. So here I am as the boot prompt. Okay. So let me reboot and just show you. This is the uboot prompt. So in a minute you will see OpenSBI booting uboot, and I have a preloaded image binary that basically has uboot as the payload. And it boots using, this is the unleashed board, that's a Sci-Fi unleashed board we have. And you see OpenSPI and booting here U-boot. And you see OpenSPI, hold on, okay. So now you see OpenSPI has been booting unleashed board using U-boot, and the rest of the things we just need to use a TFTP boot to load the image. Let's see if I can do that. Yes, so currently that's not yet done because there is no SPI driver in U-boot. As soon as somebody puts the SPI driver in U-boot, that will be possible. Okay, here I am. Guess I need to, okay, so all the network is set up. Oh, it's too below. Now if you can see that screen, can you see? I don't know, I'm just typing TFTP boot image. Hopefully it will work, we'll see. Oh, I did not set the server IP. edit the server IP not set. Was a random character?
You need to slow pace the settings. It's losing characters.
Okay, I'll just type it.
Yeah, the serial drivers are usually polling the driver.
Set.
You did type it properly upstairs. Okay. Yeah, just do the GPD boot one.
Oh, it's working. So it boots. So demo gods are not that angry with me. So it load the address with the 60. So we just copy that and put here. And let's see if it boots kernel. So ideally it should boot Fedora 29. Oh, it boots now. So this is basically the demo that I wanted to show. So you have OpenSPI, you boot, and you load your Linux image, and here is your Fedora without changing anything, without recompiling the Linux every time, and you just load your image from wherever you want. So it will take a couple of minutes to get into the prompt. Just wanted to show you it. I'm not faking those one. So any questions in the meantime? I can take a couple of questions until this boots, so it takes a bit time.
Do you have to assign vendor IDs?
Not yet. So this is all standard, whatever the existing SBI. So we have not changed anything to the SBI. Once the spec is frozen, we'll have all those implementations. And vendor ID we don't have to assign. We just get from the mVendor ID CSR, which is already given by the specific, I think, privilege spec.
How do you handle the case that those implementations might not have the JDEC vendor ID?
So the basically privilege spec, the manufacturer will not have JDEC spec ID. Is that possible? I thought it's mandatory to have the vendor ID. No.
So the question's the open source versions. So there's like the high bit in vendor ID is either open source or non-open source. And the open source ones right now are just listed in the spec. So you just get your own. There's probably in the service class privilege.
Any other question? It's still booting.
How is in the supervisor binary interface for those of us that are new but familiar with U-boot, how is this applied to the unleashed board? Because I'm confused where it comes into play. I mean, we have a GPL, U-boot.
Mm-hmm.
Where's the what's
So,
the part that's here?
So supervisory implemented SBI is implemented by the OpenSBI. So U-boot doesn't have to deal with that. So U-boot acts as the bootloader. So think it like it provides a runtime services. So runtime you need to send an API, runtime you need to perform the program the counter. So U-boot doesn't have to deal with any SBI implementation. It's Linux, the supervisor OS that actually needs to make those SBI calls. As of now, U-boot don't need that. So what all we need to U-boot is the fix the network driver, support the UART driver so that we get the U-boot prompt, and then just add the unleashed board support in U-boot. The patches are being upstream, so it should be available in mainline.
Maybe some of the confusion on the mailing list is just from an architectural point of view that everyone is nervous about having any BSD binaries in this layer. I mean, we have the ideal of the RISC-V being this open architecture unlike ARM, and we have basically that, and then GPL U-boot, and then the Linux kernel. It's like putting the BSD binaries in there is a concern, I think, to a lot of us, because we've been screwed over by that before. It seems dangerous. I would prefer that Western Digital supported a GPL implementation for this just to close out binary-only proprietary forks here is, I think, the feedback you're going to hear. You're
Okay,
certainly going to hear it from me.
Okay, yeah, sure. No, sure. So I thought.
Right? If we made a GPL, people would just write their own version because they don't want GPL code out there. And then that's worse because then everyone has their own weird implementations that don't work together. That is going to happen. It's going to be a problem. And this way, at least, it's all based on the same single core. And hopefully they'll contribute back because they'll realize it's too much work to maintain themselves. You can't make even GPL. You can't make people do it, right? If you make a GPL, they're just write it.
Yeah, we could make it really hard not to, though. I mean, we have a lot of leverage here.
No, but that's how security bugs come into play, because you have like a standard, a reference version that's well tested, everybody has to work on it, it's GPL, and because the vendors they want to add their own secret sauce there, and they cannot use the GPL version, they write everything from scratch, and boom, you get having everywhere.
And that will happen, right? If they can't use it because they will just write it themselves.
Well, they can just go use ARM. They don't need to use RISC-V. So use this architecture. They can go make their own and do a tool chain and port glibc and whatever.
They want it, which is right? We want them to use this stuff.
Yeah, we do.
Be out lost out and then say we want to use it, right?
I'd like to point out an error that I see just about everyone making. People talk about, because the current boot process, because of how simple it is, it starts out in M mode and then does almost nothing before running a kernel in S mode. People think of the privilege level as decreasing during a boot, but no, the boot process and the privilege level are perpendicular. If you have like a net boot system which requires a rich environment to build a full network stack in order to load the kernel, that means that your privilege stack and your boot order are simultaneously existing. You can have a machine mode, a supervisor mode, and a user mode while you're fetching netboot resources. You can have a machine mode, a supervisor mode, a user mode. After the boot process is completed, we can and should have a chain loading mechanism that replaces all three privilege modes. We also need more restricted chain loading mechanisms because a virtual machine is not going to have an M mode. But
Yeah.
the solution to we want to be able to give hardware manufacturers the ability to opt out of an unmodifiable M mode is not to sabotage the SBI. It's to have a defined procedure for handing over the keys.
Okay.
Giving hardware manufacturers options from a free software point of view, I think
But
that we control much more of the power than we used to, and capitulating to the requests on designs of chips that they can modify this in ways that is uninteresting, I think, to us. I don't know why we would bother even trying to help.
But otherwise, it will how the RISC-V mass adoption will happen. So
because it's going to be better than anything else. We hold all the power here.
Here also, let's say
they can go license ARM all day long and do every stupid proprietary Microsoft garbage that they do there. I think we should not help them at all. Like right now, we have enormous power as software engineers. It's almost a coup against the hardware manufacturers. We're going to define how this works.
But what if they, let's say it's a GPL, they take it and make it their proprietary, as he said, as Alistair.
Well, you're also making the implicit assumption that the GPL is still enforceable in 2019.
It is.
Yeah, okay, but
We have good lawyers.
I didn't understand the argument that if it's GPL, they're going to do what? They're going to change it. They're going to write it themselves, right? I mean, they're going to write it themselves.
Fine, they can do that.
The thing is, if you think vendors aren't going to fork this stuff, you're not living in the world I live in, where they fork it for every damn board they build.
Yeah.
So one option is you could dual license it for people who want to dual license. That solved the problem in a lot of areas.
Yeah.
Going on from the licensing, because that'll never end, I just have one quick question. Because a bunch of us talking, we've never understood, following this discussion, why you didn't put the bindings in the FDT. Because you've defined this space with 11 bits of vendor and 16 bits, and then your idea is you're going to probe that space.
which if I did my math right is 2 to the 27th times I'm going to call and say,
But-
do you do this? I don't understand why you wouldn't just put the bindings. In fact, in some sense, by not putting the bindings in the FTT, this ends up even looking worse than ACPI, and there's nothing worse than ACPI. So, I
No.
just don't understand why you're not
So-
enumerating it in tables instead of asking me to call a function
Yeah,
over and over.
I know we had that discussion, but then there are other side of the people which basically wants ACPI or something. Somebody mentioned thing we want Windows to run on RISC-V. So,
I don't get
so we don't want to cut them out. Like
I don't get that argument at all. Why? So if you put the bindings in the FTT, who is that cutting out?
so whoever doesn't use device tree. So
Okay, but
you put the data in there.
no. So put
So
it
it's-
in both places. I just don't get the problem here, right? I can't understand the idea that probing by doing repeated calls is better. And following on that, have you outlined what the costs of a call in the SBI are? Because you're asking people to call into the SBI to
But-
do a fence, which is
No,
no,
we're calling
that's
the SBI to do a remote fence.
okay.
Yeah.
Interrupting another heart to do a fence. on
Okay,
another
you're right.
heart.
But
So-
still, what is, like, we had this discussion. I was out
Think
at
of
low
the
risk the
then
last 2
barrier
days,
system
and
call.
when you drop into the SBI, you're going to probably, in most cases, have to blow all the pipelines out. So what are you looking at in terms of a cost to SBI?
No,
Have you listed that or enumerated it? Or
not yet, but that's why we had that thing. I think you mentioned thing. We should be able to replace any of the S mode, by S mode. So let's say tomorrow there is
Yeah.
the timer one. There is a architecture register. We go and replace it. So let's say there is a better way to do the IPI or TLB flushing. We go and replace it. That's why those are, as of now, is not mandatory. Those fall under legacy. But to answer your question regarding the initial probing, the assumption is here is it will all happen in early boot. So you just query in the beginning and whatever feature you require, and just store it in a bit mask or some feature. Still think it will be.
I mean, we have the Verilog of VHDL here. I mean,
Yeah.
ultimately, we answer that question ourselves.
yeah, well, I mean, there's at least one company I know that's not going to have them in the processor. But
The counterpoint of what I
Yeah.
just said is that runtime services should require the smallest possible amount of privilege, and the stuff like remote fences can and should be done entirely in S mode.
yeah,
But,
Yeah.
but that requires
Hey,
firmware interfaces which are separate from the SBI.
And another thing I don't see going on at all in any of this is any kind of verified boot. Any thoughts
Yeah.
around verified boot, and it just seems like there's no consideration of any of those issues in here at all.
So that's what I'm saying. So all those things will at least fall into place. So that's why we wanted to focus on the first get the base SBI, so that at least we get it done, and then any, let's say, verified boot, power management, we keep on adding it.
Yeah.
But if we keep, like, from the beginning of the discussion, we keep diverging to verified boot and
Yeah.
let's say power management, things doesn't
So-
get done.
And I'm sorry, the final thing I thought about is in core boot, our use of this would be to compile it in, which we would not use it as a .a, because I've looked at your code, and you've got a lot of things that will clash with names in core boot, like, for example, printf. And so it just a take-home way for you, it'd be neat if, and we can work with you on this, it'd be neat if you could think of ways that something like core boot would say, gosh, they've done a nice job on a lot of this actual implementation, but they want to compile it in, right? We're not going to use it as a .a. So
I think that's fine. That should be fine. Yeah.
No, it's,
Yeah. That's what
there are ways you could have structured things that make it hard. It doesn't look like it'll be hard for us to do it. But
Yes.
It's just, I just wanted to get it out there.
We're interested.
So I think that was the initial motivation to have most permissive license, that anybody can use it. But I understand the argument, but eventually you think, like, if we restrict it, then people will just write their own, then we will not able to enforce anything with that. But at least if keep using, let's say vendors keep using OpenSBI, then at least we have a way to enforce everything. What we accept in kernel, what we accept in OpenSBI is up to the group. So
I mean, we're talking about minor amounts of code, and your argument from a vendor point of view is that there's some intellectual property that some investment banker cares about in a trivial bootloader at the beginning of code where it's all free on every single direction. There's no corporate argument here. Like, whoever, I mean, we'll force that down their throats then.
No, there's some vendors might have there's some secret sauce, for example, for power management that they don't want to disclose, and they don't want to let you read the driver. So if you have
So we're out of time.
Yeah.
Keep talking about that.
Okay, yeah, we can talk about it. And as I said, like, it says RISC-V, so we have complete booting flow.